Hi friends, today in this lesson we are going to deal with the application of Gauss's law. So just before starting Gauss's application of Gauss's law, let me tell you one thing. We have already learned the Coulomb's law. What is Coulomb's law is talking about? Why it is used for? It is electric field due to. It is used for find the electric field due to a point charge. Where we are using Gauss's law, it is used to find the electric field intensity due to symmetric charge distribution. Not a single charge, symmetric charge distribution. So just come to the first application. We are using due to infinitely long, straight, uniformly charged wire. So that is the first application. Just think about this one. Consider we have an infinitely long wire, just a wire, and just imagine on the wire there are charges are uniformly distributed. Just imagine the charges were distributed here. All are positive charges. All are positive charges. This is an infinitely long wire. So once again, if this is a wire, on this wire there are many charges are placed distributed. Okay, so this is the case. Now we are going to find out what is the electric field. Maybe you can say here this is a point P. We are going to find electric field at the point P. So how to find? By using Gauss's law. Okay, that is the one we are going to discuss. In order to derive this one, not explain this one, we should consider including this point P. Just imagine there is a imaginary surface or a closed surface. As you already know, while you are using Gauss's theorem, it must be what? A closed surface. So if you just imagine a closed surface, you can see here around a uniformly charged wire, the closed surface shape will be like this. So what is the shape of this closed surface? It becomes a cylinder. So what is this dotted line represents? This dotted line represents a Gaussian surface. Which surface? Gaussian surface. Okay, let me tell you once again. This is a wire. This is linear charges are distributed here. Just imagine this is a point where we are going to find the electric field intensity due to which one? This charge distribution. So if you consider a imaginary surface, you can see here this is a shape of cylinder. Clear? So this is a one diagram is shown here. So for this, just imagine the radius of this imaginary cylinder or a Gaussian surface or Gaussian cylinder is radius r, and the length of this cylinder, say it as L. Charges are distributed here, and this is length L and this is radius r. Now we are going to find what is the electric field at the point P. In order to find the electric field at the point P, what we should consider here, a very small area, say it as delta S. What is delta S? A very small area. And always, area vector will be perpendicular to the surface or normal to the surface. Now just imagine this is the positive charges are here. So due to this positive charge, what is the direction of electric field at the same point P? You can see here the direction of electric field will be in this direction. Will be in this direction. That means vector E vector as well as area vector both are in the same direction. So what is the angle between these two vectors? That is theta equal to 0. Now you are going to apply Gauss's theorem. Using Gauss's theorem, as we already know, phi is equal to Q divided by epsilon 0. Phi is equal to Q divided by epsilon 0. So what is phi here? That is electric flux. And you have already learned electric flux phi is equal to E vector dot delta S vector. That is phi is equal to E delta S cos theta. Here theta is equal to 0. So we can write the phi is equal to E into delta S. Cos 0 is equal to 1. So we got two equation number 1 and here equation number 2. You can see here both left hand sides are equal. So what you can write here? Q divided by epsilon 0, or you can simply write the E delta S is equal to Q divided by epsilon 0. Q divided by epsilon 0. Now just imagine this is the electric field into small area. If you want to find the entire area, that means if this is a closed surface, around this one closed surface, what is the shape here? Cylinder. So it's a small area we have taken. If you find the whole area, what is the equation become? You have to use here summation all the surface E into delta S is equal to Q by epsilon 0. That is E into summation all surface delta S is equal to Q by epsilon 0. So what is the total area, surface area of the cylinder? That is equal to, we can write the E into summation means the entire area. We can integration also can be used here. We are using summation. So E into 2 pi R L. E into 2 pi R L, that outer surface of the cylinder. Outer surface of the cylinder. E into 2 pi R L, which is equal to Q divided by epsilon 0. Clear? Now next one is that we have to find out here the charges are distributed uniformly. Charges are distributed uniformly. So we have to use one term here, that is the charge density. Charge density. Here the charges are distributed linearly, so we can say that linear charge density. We used to represent this one as lambda. So what is the linear charge density? Lambda is equal to charge per length. Charge per length. We have considered this much length of this wire. So total charge is Q. Total charge. Q is the total charge Q per length. This is the charge density. So lambda is called what? Linear charge density. So from this equation, we can write the Q is equal to lambda L. Q is equal to lambda L. So what is the total charge now we are using for this imaginary cylinder or a Gaussian surface? That is equal to lambda L. Can come and substitute here in this equation. Now you can write here E into 2 pi R L is equal to, so what is Q stand for here? Lambda L. Q stand for lambda L. So lambda L divided by epsilon naught. See, the length of the cylinder is cancelled. So electric field E is equal to, I can write like this, lambda divided by 2 pi, just close here, 2 pi epsilon 0 into R. So this is the formula used to find electric field intensity due to this charged wire at the point P. Now this is not a vector notation. If you are writing in vector notation, you can see here electric field E is equal to lambda divided by 2 pi epsilon 0 R into R cap. So that is a unit vector, R cap. What is the direction of unit vector? You can see here in this direction. Because it's a positive charge, so you can see here the R vector is in this direction. Okay, so what is the conclusion from here? Electric field is inversely proportional to R. E is inversely proportional to R. If you draw a graph connecting electric field along the y-axis and radius or the distance from the charged wire is R, what is the shape of the graph become? The shape of the graph become a rectangular hyperbola. That means if the point P is somewhere here from this charged wire, electric field intensity keep on decreasing. Keep on decreasing. So this is the first application of Gauss's law. So once again, let me conclude here. We have used or we have applied the Gauss's law only. Why? What is the reason here? Because there is not only one charge, but there are symmetric charge distribution. There are many charges are there. So in order to find the electric field at the point P, we have applied the Gauss's theorem and we have calculated the final equation E is equal to lambda divided by 2 pi epsilon r into unit vector r. So there is a one new thing, maybe you may not be know this one, that is a linear charge density. Why we use the linear charge density? Because the charges are distributed uniformly. So there we are using the term linear charge density and we are representing lambda, that is equation is charge per length. Charge per length. So we have calculated, we have derived the formula for electric field intensity due to infinitely long straight charged wire. I hope you understand this topic. Thank you.